morning, one and all. Myself, Yashvi Sheth, and today we are going to have the ninth live session for the course Basic Principles and Calculations in Chemical Engineering, taught by Professor Subrato Majumdar from IIT Guwahati. So let's start with the session. I will share my screen. Yeah. So, in this session, whatever we have talked about in this course is all about material balance, energy balance. Okay, so far we had discussed that for any balance, if I want to apply, then what like it can be anything material balance or energy balance. So, in both the cases, we had written a general equation, balance equation, as accumulation in the system is to input to the system minus output from the system plus generation within the system minus consumption in the system. Okay, so so far we had considered a continuous or steady state system. Okay, so for steady state system, what happens is accumulation is nothing but it is change in either mass with respect to time, or either for this is for mass balance, and for energy balance it is change in energy of the system with respect to time for energy balance. Okay, so for steady state process, we consider dm by dt and de by dt tending to zero. Like it will be zero because there will be no change with respect to time in steady state process, because for steady state process variables do not change with time. Okay, so now moving forward, for like so far we had discussed balance, like material and energy balance over steady state systems. Now we will start today unsteady state balances. Okay, so material and energy balance for unsteady state processes. So what are unsteady state process? Unsteady state processes are the process in which the quantities or the operating condition within the system they change over the period of time. So this can be mole fraction, or you can say concentration, okay, of product reactant, or if reaction is not occurring, if it is just a physical process, then also there can be some concentration variation in the in different phases, okay, temperature, pressure, etc. Okay, so all these parameters they change with respect to time in unsteady state process. And example of unsteady state process is nothing but batch processes. Okay, and these type of processes are also known as transient process, because there is transition occurring, there is no constant thing attained. So this is the general material balance equation that I had written. So accumulation of mass within the system would be equals to input to the system minus output from the system plus generation within the system and minus consumption within the system. Okay, so if I want to write in terms of mass, then what can be written as, so dm by dt. Okay, here it will be just mass because change in mass with respect to time itself will be a kind of flow. Okay, so now since this is in mass, which is kg per unit time, which is in, let's say, second, so this is in kg per second. So to equate that, whatever whatever will be on the right hand side of the equation, that has to be in the type of flow. So this is nothing but mass flow. So we need everything on the right hand side to be in the form of flow rate, which is nothing but mass flow rate, and it is denoted by m dot. Okay, so what will be the input to the system? Let's say this is the system. We have m dot in, we have m dot out. Okay, so some reaction is occurring, and for that there is certain amount of m which is generated by the reaction. There are two parallel reactions, so there will be certain amount of generation and there will be certain amount of consumption. So generally we can write that in general m in minus m dot out, which is the outlet, plus whatever may be the generation minus consumption. Okay, so here if we like, we can write either overall also, overall balance, or we can write component wise balance. So in that case, generation and consumption terms can be obtained from the rate equations, because generation and consumption occurs because of the reaction. Okay, so whatever may be produced or consumed, it can be obtained by rate of reaction is nothing but dc by dt minus dc by dt k c raised to n. Okay, so from this type of equation you can get generation or the consumption term. So generation will be for products and consumption will be for reactants. Okay, so now for steady state process, we had this dm by dt term equal to 0. We took it as 0 because with respect to time there was no change. But now since we are talking about unsteady state process in batch processes, so this term which is with respect to time, so change in mass with respect to time in the system will not be equal to 0. Okay, so this term cannot be neglected if I want to perform any material balance over unsteady state process. So similar concept can be applied for unsteady state energy balance equations. Okay, so this is the general energy balance equation. So this we had derived earlier. Okay, so what type of so this is the total energy with the system. Okay, so if I am taking delta H, so that is nothing but change in the total enthalpy or the total energy of the system. Okay, plus U square by 2 because the system might have a bulk flow, plus Gz, which is due to the potential it has. Okay, so that all terms are added, and since all this will be in terms of joule per kg, and I want with respect to time, so I am multiplying it with mass flow rate. Okay, so this will give me the energy input minus output. Since this is delta, so already input minus output is taken care of. Now generation within the system can be due to reaction occurring. So generation occurs when the heat generation occurs when there is exothermic reaction. because exothermic, in the exothermic reaction, delta H is negative, which means energy is released. Okay, so that term like that has to be added. So that delta H will be added in here, which is the generation term. Consumption term will within the system will be there can be certain amount of, so for consumption it can be due to endothermic reaction, because for this delta H is positive, which means energy is consumed within the system. So energy is consumed. Okay, so that much amount needs to be subtracted. Also, there can be shaft work, or there can be some heat dissipation. Okay, so all these needs to be considered. So here I am adding Q dot, which was the general way of writing. So Q dot is the total amount of heat added to the system, and this is nothing but shaft work. So that is nothing but equal to the change of energy in the system, which is nothing but dE by dt. Now for steady state process, we can write as like this to be 0, dE by dt to be 0. But for unsteady state process, dE by dt will not be equals to 0, and it will remain. So there will be some energy change within the system with respect to time. Okay, so for closed system here, as it is given, since we can write change in, like for especially for liquids and solids, change in pressure and volume with respect to time can be neglected. So as per this equation, H equals to U plus PV. So if I apply change over here, so like dH by dt will be nothing but du by dt plus d of pv by dt. Now since dpv by dt is 0, then you can say that dH by dt equals to du by dt. Okay, so for this case, energy can be represented either in terms of internal energy, or it can be considered as enthalpy also, and that is nothing but the total energy change of the system. So moving forward with the assignment, first question is given as which of the following option is correct. So this question deals with the general balance which I had shown, may it be material balance or may it be energy balance. So how can we write the balance equation? It is nothing but accumulation equals to input minus output plus generation minus consumption. So if we look into the options, then option A is correct. Okay, so A is the correct answer here. Now, in a closed system, the rate of change of energy inside the closed system is nothing more than the rate of change of internal energy, which in turn is essentially same as the rate of change of dash. Okay. So this is what related, just a second. So yeah, this question is basically related to what concept we had discussed. Okay, so here we are given a closed system. So for closed system, we know that the like change of P into V with respect to time is zero. Okay, so we can say that, and here what is given as, this is the data given. So dE by dt inside a closed system is nothing more than, which means nothing more than is a key term here, which means it is almost same or it is equal. Okay, so dE by dt is nothing but du by dt. Okay, so rate of change is nothing but change with respect to time. So rate of change you can write as change per unit time, change of quantity per unit time. Okay, so here this was just discussed few minutes back. So since dpv by dt is 0, then you can say from this equation that dh by dt equals to du by dt plus dpv by dt. Okay, so since this term is 0, then you can say that dh by dt equals to du by dt. So now since du by dt is nothing but de by dt, so you can say that, which in turn is essentially same as the rate of change of enthalpy as well. So H here is enthalpy, U is internal energy, and E is the energy of the system. Okay, so here the correct answer is change in enthalpy. Yeah, so change in enthalpy is the correct answer. Next question is a vessel containing 5 liters of water at 50 degrees Celsius having specific heat and density given in the data is heated for 100 seconds. Now one electric heater is attached to the vessel to heat the liquid, and it is supplying heat at a rate of constant rate, which is nothing but Q equals to 2500 joules per second. Now, how can you say that Q is constant? Like the heat supplied is constant, because if heat supplied will not be constant or it would be varying, then Q would be a function of time. So in that case, you can say that it or it can be a function of some flow rate or something else. Now, since electric heater it is used, the supply will be at a constant rate, which is nothing but 2500 joules per second. Now you need to find out here the final temperature of the water after 100 seconds, and also the equation that can be used for finding out the final temperature after 100 seconds can be used. So here T is the temperature, Q dot is heat added to the pan. So all the variable are given here. So to solve the question, so let's uh, say here you have a pan. Okay, so there is 5 liter of water. Okay, 5.0 liter of water here present at 50 degrees Celsius, and now you are heating it, okay, with Q equals to 2500 joules per second. and for t equals to 100 seconds, from t1 equals to 0 second to t2 equals to 100 seconds. Okay, so this is the differential equation already given to you. So if you want to derive this equation, that can also be derived. Okay, so how can that be derived? So dE by dt is nothing but like m dot delta H. Okay, uh, yeah, this equation m dot delta H minus m dot delta H plus delta U square by 2 plus dz, okay, plus q dot minus w dot. Okay, so since there is no flow here, u can be 0, gz will be 0 because there is no mention of such thing. Okay, uh, shaft work is given. There is no shaft work involved here because there is no rotor given, so this is also 0. Okay, and next term is enthalpy change can also be 0. So what remains is dE by dt equals to q dot, and which means that now E is nothing but H over here or U over here. Okay, so you can write as dH by dt equals to q dot, and dH is nothing but d of mCp delta t. Okay, mCp into t divided by dt equals to q dot. Now if I look into the equation, then m and cp, if they are constant with respect to time, then I can take out of the differential and I can write as d like m cp dt by dt is equals to q dot. Okay, and which means dt by dt equals to q dot by m into cp. And if I want to write m in terms of density into volume, because you are given volume of water, because since water is a liquid, uh, is liquid, so volume is the better way to represent. So I can write mass in terms of volume, so which is nothing but rho into V into Cp. So this is how you derive. Okay, so yeah, to solve it further, you just need to solve the differential. Okay, so how will you do that? So the differential term is dt by dt equals to q dot rho vcp. Okay, so you just need to integrate. Okay, so to integrate, let's ti to tf equals to q dot. Since all these are constants, you can just take out of the integral. Okay, I am not writing inside the integral. Integral from t1 equals to 0 seconds to t2 equals to 100 seconds, and here t1 or ti is nothing but 50 °C dt. So if you solve this, then T final minus T initial is equals to Q dot by rho VCP into delta T. Delta T is nothing but T2 minus T1. So if I put up the values, TF minus 50 equals to Q is given as 2500 joules per second divided by rho is in so yeah, rho is given as 1000 gram per liter. Then Cp is given as 4.18 joule per gram degree Celsius. Okay, and yeah, time is given in seconds. So yeah, if we keep like, since rho and Cp they both are in gram, so you do not need to change the unit. And also volume is given in liters, okay, 5 liter. So density is also in gram per liter. So everything will get balanced. So you don't need to change the unit. Otherwise, the simplest way is to convert everything into SI if you get confused, okay. So that also can be done. Here there is no need to change because 1000 gram per liter into 5 liter, so liter will get automatically cancelled out, into 4.18 joule per gram degree Celsius. Okay, so gram will also cancel out, joule will also cancel out, and yeah, into delta T is 100, so which is in seconds. So seconds also get cancelled out. What remains is nothing but degree Celsius. So if you put up the values and if you solve this, what remains is 2500 into 100 by 1000 by 4.18 by 5. It is nothing but coming as 11.96 degrees Celsius. So this is nothing but delta T. Okay, delta T is 11.96 degrees Celsius, and since you know the initial temperature, final temperature would be nothing but 50 plus 11.96, which is 61.96 degrees centigrade. Okay, so if you look into the options, our T final is coming as 61.96 degrees Celsius, which you can say it is all equivalent to 62 degrees Celsius. So correct answer is 62 degrees centigrade. So moving forward to the next question. Concept of material balance is based upon dash. So obviously concept of material balance is nothing but I apply mass balance. So it is based on the law of conservation of mass. Next question is, when Q equals to 0, there is possibility that Q that is equals to heat given or taken to the system is dash. So temperature of the system and surrounding are same. System is an adiabatic, system is adiabatic, both A or B or neither. So you can say that when Q equals to 0, you can say either net Q is 0, okay, or there is no heat transfer. So net Q is nothing but delta Q. Okay, so what happens is usually, so this is the system and this is the surrounding, okay. This is at T1, this is at T2. Okay, so there will be certain amount of heat if T1 is greater than T2. There will be certain amount of heat which will be depending on the temperature gradient, which will be delta T by delta X. So depending on that, there will be some transfer of energy from T1 to T2. Okay, so it is not necessary that there will be just motion from this direction. There will be certain like at the later stage, there can be reverse also. Okay, so at certain point of time, equilibrium will be established. Okay, because the temperature gradient or the heat content of both is 0. So until and unless there is no unequal heat content in the system, which is denoted by unequal temperatures, so until and unless both the heat content are 0 equal, then till that point of time there will be some net transfer of heat from one system to surrounding or from surrounding to system. So once they both the heat content are same, then there will be net 0 transfer. Okay, so delta Q will be 0 because since both have equal heat content, there are no chances that like equilibrium will be there. So there will be no change. Like there will be molecular change, but bulk, if we look at bulk, then it will be same. So if the temperature of system and surrounding are same, then in that case delta Q will be 0 because the system will be in equilibrium like with the surrounding, and so delta Q will be 0. And also the adiabatic system itself means that there is no heat exchange. Okay, so both the options are correct here. Now next question is, the unsteady state process is also known as this. This is nothing but the another phrase which can be used. So it is nothing but transient process. So unsteady state is also known as transient process. Next question is, if no heat is transferred to or from the surrounding, then the process is called as, okay, so if there is no heat transfer, obviously I told you that it is adiabatic process. So if we look into the other options, isothermal process is the process. So what are its meaning? So isothermal process is process in which change in temperature is 0 or delta T is 0. So you keep the temperature constant. So temperature is constant throughout the process. Next is isentropic. So you can, yeah, there is another way of remembering. Isothermal means it is related to energy or temperature. So iso is no change. Iso is no change, or also you can say constant property, which iso is constant. Okay, so isothermal means constant temperature. Now here isentropic means there is iso plus entropic. Okay, so it is nothing but constant entropy process. So delta S is 0 for this case. So here when there is no heat transfer, it is nothing but adiabatic process. Now next question is, there is a saturated solution of a compound that contains 40 gram per 100 gram of H2O. So what does saturated solution mean? So there is this solvent and you keep on adding solute. So there is some solubility of this solute in the solvent. Okay, and depending on the solubility, there will be certain amount which gets completely dissolved in the solvent. So that is a limit. Like now if I add above that limit, then it will not be able to dissolve in that solvent further. So saturated solution is when you are achieving the limit and above which there will be no further dissolution. Okay, so 40 gram per 100 grams means you can maximum dissolve 40 gram of solute or compound in 100 grams of water. So this is the saturation given to you. Now a test run starts with 20 kg of compound to dissolve in 100 kg of pure compound. Okay, for which solubility is given as this. Now it is found that 5 kg of the compound is dissolved in 3 hours. Derive the differential equation for the undissolved solid with respect to time. Okay, so there will be some gradual dissolution like with respect to time, because not all will dissolve at the moment. Okay, so with time the amount which is left in the solid form will reduce, which is the undissolved solid will decrease with time and soluble solid will increase with time. Okay, so the rate at which the compound dissolves in the solution in water is given as this equation, which is nothing but Rd equals to K into N CSS minus CAS. Now obviously if you want to understand this equation, then as I mentioned that there is certain limit at which like limit up to which water will be able to dissolve the particular solid. Okay, so if I am moving towards the solubility limit, okay, so lesser and lesser gradient will be there. Okay, so everything depends on the gradient. So rate will obviously depend on what, like how far is the solution, because if I have two solutions, okay, and let's say I am dissolving sugar in water. So, let's say sugar has a solubility of 10 gram per 100 gram, or let's say 50 gram per 100 gram of water. Okay, so I have 100 grams of water in both. Okay, now in one water is already there, and in one beaker I have 70, like already 50 grams of sugar, and in another I have 30. So still this has 20 more gram of sugar can be dissolved. However, the further sugar cannot be dissolved here. So even if I add sugar to this solution, it will not get dissolved. So how much will be dissolved in the solution further? It will depend on how far my solution is away from the saturation. So rate will be proportional to how far my solution is away from saturation. So which is nothing but C saturation minus actual, which is dissolved, actual concentration of solution, into also how much I have added. So how much is in solid form. So it also depends on the number of, or the undissolved solids, or what I have added. Okay, at that moment what is present. Okay, so if I combine these two and remove the proportionality constant, so K is the proportionality constant here. Okay, so this is how this rate equation is derived. Now if I want to find out this differential equation for undissolved solid with respect to time, it means I need to find out dN by dt. Okay, so to find out dN by dt, what we will do, we will write a material balance equation. So what is material balance equation that can be written? Accumulation was to input minus output plus generation minus consumption. Okay, so here there is no input or output to the system because it is a batch process, so this will be 0. Okay, so accumulation is nothing but what remains in the system at that moment of time, so it is nothing but dN by dt. Okay, so it will be nothing but, so N is obviously consumed, so it will be RD because it is the consumption rate. So you can write this as, sorry, Kn CSS minus CAS. Okay, so this is the material balance left. Now you just need to solve this. Okay, dN by dt equals to, now CSS is a constant term which is given as 40 gram per 100 grams. Okay, so it is nothing but given as 40 by 100, so you can just put it here. Now CAS will be variable, like what is present in the solution, it will be variable term, and in terms of N you will have to write, because two variables at a time you will not be able to solve the equation. So you to convert into single variable form, so at any moment if I want to apply solute balance, which will be nothing but, the total added, okay, so total input equals to in the solution plus solid form. So in the solution is nothing but CAS plus like NAS plus, which is undissolved, solid undissolved, so it is nothing but N. So number of moles which is present in solution, it is nothing but N, 20 minus N. So if I want to find out concentration, so it is nothing but 20 minus n by what is present? Total. So total is 20 is dissolved in 100, so it will be 100. So now I just need to put up the values. So k into n, it will be 40 by 100 minus 20 minus n by 100. Okay, so I will take this n in the denominator. 1 by n dn equals to k. Now this denominator is constant, so I can take that out. K by 100. 40 minus 20 will be 40, and minus minus will be plus n. So this is what will remain into dt. So 1 by n, I will take n at one side, 1 by n, 1 upon n into 20 plus n dn equals to k by 100 dt. Okay, so this is what the in this form is only asked to give you the answer. So option A is the correct answer if you look into the options. So I hope it is clear to all. Now moving forward to the next question. A single effect evaporator is fed with 10,000 kg per hour of weak liquor containing 15% caustic by weight and is concentrated to get thick liquor containing 40% by weight caustic. Now calculate the rate at which thick liquor is formed. Okay. So here let's understand this schematically. So this is the single effect evaporator, or the process you can say, in which it is going on. So I am having a feed which is going at a rate of m dot n is nothing but 10,000 kg per hour. Okay, and it is having concentration of caustic in it as 15%. So you can say that in this solution, out of 10,000, 15% is my caustic. So 15% of 10,000 is nothing but 1500. Okay, so since this is in kg per hour, so fraction will be also like caustic flow rate will be also 1500 kg per hour. Okay, so at this rate, the solution rate into the system is 10,000, and total caustic which is going into the system is nothing but 1500 kg per hour. Okay, so now it is given that the evaporator concentrates the liquor till 40%. Okay, so now what an evaporator does, it evaporates water from liquid to vapor. Okay, so what will be the case? There will be no change in the solute in the solution, like the amount of solute in the solution will be same, but the amount of solvent, which is water, is removed by evaporating it. So okay, so amount of water in the solution will be lesser and lesser because it will get evaporated, and that is how you concentrate. So here you can say that there will be no evaporation of caustic, there will be just evaporation of water. So whatever is the caustic going into the evaporator, same amount of caustic will be coming out of the evaporator. Okay, so 1500 kg per hour will be caustic in the outlet also. But at this point, now 1500 caustic, it constitutes of 40% of my liquor. Okay, this which is nothing but 40% solution. So if I want to find out the entire flow rate or the flow rate of the thick liquor, which is nothing but 100% solution, so you just need to cross multiply. So for 100% solution or thick liquor, what will be the total? Okay, because 1500 kg per hour corresponds to 40%. So for 100%, what will be the flow rate? So this is nothing but just a matter of cross multiplication, and if you do that, the total flow rate of thick liquor will be, because 40% is caustic constituent and 100% will be total thick liquor. So if I find out 100%, then that will be nothing but total flow rate of thick liquor, which will come out to be 3750 kg per hour. So this is the answer for this question. And now moving forward, next question is, if dPV by dt is 0, then what is the correct thing? Okay, here Cp and Cv are nothing but heat capacity at constant pressure and constant volume. Okay, so here you are given dPV by dt. So earlier is equals to 0. So earlier we have derived this 2 times. dPV by dt nothing but implies that dH by dt equals to du by dt. Okay, so for H and U, you can write as Cp, like d of mCp t by dt equals to d of mCp mCv, sorry, because for U it is Cv, t dt. So here you can say that since these two are constants, m is a constant term here, so that can be cancelled, and dt will, like Cp and Cv, if you consider that to be constant with respect to temperature or with respect to time, so that can also be taken out, but nothing but will remain dt by dt equals to Cv dt by dt. So these two will also get cancelled up, which means Cp equals to Cv. Okay, so B is the correct answer. Moving forward, a pan of water containing 1 liter of water at 0 degrees Celsius is placed on an electric heater with heat where heat is supplied at a rate of 2500 joules per second to increase the temperature of water to 60 degrees Celsius. Okay, now calculate the time required to raise the temperature. Here the specific heat at constant pressure is given as this. So this is the question which is similar to what we had discussed, but at that in the previous question you were given, like, for this much time you are heating, so what will be the final temperature, but here you are given the temperature change and you need to find out how much time will it take. So it is nothing but more or less same. So similar equation you will use, which is nothing but dt by dt equals to q upon m into Cp. So m obviously you can write in terms of q dot by rho v Cp. Okay, so if you integrate this equation, it will be nothing but delta T equals to q dot by rho v Cp into delta small t, which is time. So delta T is nothing but, so initial will be obviously T 0, so T minus 0 will be just T equals to delta T is 60 minus 0, which is nothing but 60 into rho. Rho of water is nothing but 1000 gram per liter. Okay, so take everything in gram and liter, into volume is 1 liter, into Cp is given as 4.18 divided by 2500. Okay, so if you solve this, it will come out to be 60 into 1000 into 4.18 divided by 2500. It will come out as 100.32. Now this is in seconds because here it is in second. Okay, now all other terms do not have time, just q has time, which is in second. So it will be time you will get from this equation is in seconds. Now options are in minutes. So to convert this in minute, what you will do, divide 1 second equals, sorry, 1 minute has 60 seconds. So if you have 100.32 seconds, then what will be the minute? You divide it by 60. So that much minutes will be there. So it is nothing but 1.672 minute. So within this much time, you will be able to heat the water, 1 liter of water, when there is electric heater at which supplies heat at this much rate. So within 1.6 minutes, you will be able to heat the water. So this is the answer, 1.672. Moving forward to the next question. In a sewage treatment plant, a large concrete tank initially contains this much liquid and 10,000 kg fine suspended solids. Okay. So here you have this sewage treatment plant, STP. Okay, so it is having 4,40,000 liters of liquid. Okay, and it has 10,000 solids, suspended solids. So let's say it is SS. Now to flush this material, water is pumped into the vessel. So there is water coming into the system at a rate 10,000 liter per hour. Okay, and the liquid containing solid at the same rate is coming out. Okay, so what is happening in this is there is already this much present. Okay, and you are adding water into it, which so it will not have solid. So SS in this will be 0. So this is pure water. Okay, and you are constantly stirring this. So there will be certain amount of solid, like which will be, so there will be some dilution, and whatever will be the concentration present in this solution at any moment of time, that concentration will be coming out here. So let's say as the time passes, as you are adding more and more amount of water, the concentration of solid suspended solids will decrease because more water is coming. So the dilution will occur, and since the constant stirring is applied, whatever concentration is into the system, same will come out. Okay, so let's say uh, the concentration of solid is represented by C, and so C in is nothing but 0 because pure water we are going in, and there will be certain concentration C out. Okay, which is coming out since there is constant stirring. So whatever is coming out will be the one which is present inside. So you can say that in the tank also there is C out. Okay, and let's say the tank has volume V. So the given equation is this, and you need to estimate the concentration of suspended solids in the tank at the end of 3 hours, because obviously as the time increases, more and more water is getting added and certain amount of solid is taken out of the system. Okay, so the dilution in the system will occur and the concentration will reduce with respect to time. So you need to find out what is the concentration which is remaining. So to find out that, you are given with this equation dVc, which you need to use. Okay, equals to, which is nothing but material balance equation. So how is it mass balance? So it is nothing but obtained from mass balance, because mass is nothing but, so concentration is mass per unit volume. So if you multiply it with volume, or volume in liters, so what will remain is nothing but mass. Okay, mass per unit time, because volume is in liter per second. So it will remain as mass flow rate. So similarly on the right hand side, so if you want to solve this, here you can say that V in is given as 10,000, and also V in equals to V out equals to 10,000 liter per hour, and V is given as 44, like 4,40,000 liters. Now if I like, since V is a constant term, so dC out by dt, because since only the outlet concentration is varying, you can write C as C out equals to V in into C in. Just a second. Now this Cn is given as 0 because there is no suspended solids in the inlet flow of water, minus V out is given as 10,000 obviously into C out, which we need to find out. Okay, so this will get 0. What remains is V dC out by dt equals to minus V out into C out. Now if you solve this, it will be 1 upon C out dC out equals to V out by V dt. So just a second. Now you need to integrate this equation to solve. So okay, taking integration on both the sides, 1 upon C, integral 1 upon C out. So initially what, from initial concentration, which is nothing but, initially what is there? 10,000 by 40,000. Sorry, so C out in like I, C out at time t, like you can say t equals to 0, at t equals to 0, at t equals to 3 hours, dC out t equals to 0 to t equals to 3 hours, dt, and V out by V is obviously a constant term, so that can be taken out of integral. So 1 upon C is nothing but, if you take the integral, it will be ln C out from limit C out at t equals to 0 to C out at t equals to 3 hours equals to dt. Integration of dt is nothing but delta t. So it is 3 hours minus 0 hours into V out. So V out is nothing but 10,000. So this is also in liter per hour. So R, you do not need to consider any change in the this unit, and volume is given as 440,000 liters. Okay. Now initial concentration at t equals to 0 is nothing but 10,000 by 440,000. Okay. So it is nothing but 1 by 44. So if you put ln, so it will be nothing but ln C out minus, like at t equals to 3 hours, minus ln of C out at t equals to 0 hour equals to 3 into 10,000 by 440,000. Now if you put up this value, ln C out will be nothing but ln of 1 by 44 plus this term, okay, 3 into 10,000 by 440,000. And to find out C out, you need to take, yeah, sorry, there will be a minus term here. Yeah, there is a minus term here. Okay, so this will continue. So this minus will remain. Okay, and so it will be nothing but exponential of this term. If it is x, so exponential of x, ln 1 by 44 minus 3, there will be minus term, don't forget. Okay, so if you calculate this, then it comes out to be 0.021 kg per liter. So if you have any doubt so far, you can say, otherwise we will move forward. So next question is unit of CV is dash. So for that, what we will do, what is the significance of CV? So CV is nothing but energy which is stored in, or energy which is consumed by 1 unit of mass of or material to raise its temperature by 1 unit. Okay, so here it is nothing but energy. If you write in terms of expression, it is nothing but energy per unit mass per unit time, sorry, temperature. So if you put up the values, energy is in joules, mass is in kg, and temperature is in Kelvin. So unit of CV will be joule per kg Kelvin. Option B is correct. Next question is which one is true for from the following equation? So this is nothing but the expression which we usually use. So H is U plus PV. So this is the correct equation, which is option C. Next question is the internal energy of a system is a function of, obviously it is just dependent on the temperature, because temperature will affect the motion and the energy of the molecules, and that is how internal energy changes. So it is just dependent on the temperature. So dash signifies the amount of heat and work that was added or removed from the system. So this question is related with energy in relation to heat and work. Okay, so this is obtained from the first law of thermodynamics. Okay, so it says that U is nothing but related to the total amount of heat added or work done, as U equals to Q minus W, like delta U is Q minus W. So here you can say that internal energy signifies the total amount of heat or work that was added or removed from the system. So for this expression question, internal energy is the correct answer. Next question is, if no heat is added or transferred to and from the surroundings, then the process is said to be adiabatic, because this is the repeated question. So I had already explained. Now next question. An adiabatic stirred tank is used to heat a solution. Okay. So you have this tank and it is said to be adiabatic. Okay, so what does that mean? Net heat transfer from the system to the surrounding is zero. Okay, so there can be some heat, so there is no heat transfer here with the surrounding. Now here you are given as Cp is 3.54 joule per kg, and electric coil is delivering the heat at a rate. So this reactor is surrounded by electric coil which is supplying heat at a rate of 3 kilojoule per second, okay, with full efficiency. What does this signify? Like, which means that whatever amount of energy is given by this electric coil to the system, all the amount of energy is utilized by the material or the solution inside the reactor to increase its temperature. Otherwise, there can be some dissipation, and in that case, it is not utilized at a full efficiency. So here, full efficiency means whatever energy supplied by the electric coil, total amount of energy is utilized by that solution for increasing the temperature. There is also stirring provided, which means that shaft work is given as W shaft is given as 600 watt. Here Q dot is given as 3 kilojoules. Remember, it is kilojoule per second, which is nothing but 3000 joule per second. Now, how much time will it take to reach 90 degrees Celsius from 10 degrees Celsius? Okay, so if I write the energy balance equation, so it is nothing but dE by dt is equals to, now the entire first term of del m into delta H will be not present because there is no change in energy with respect to surrounding. Also, there is no motion of the system, so first term will disappear. Q dot minus W dot will only remain. Okay, so if I simplify this E, it will be nothing but mCp dt by dt equals to Q dot minus W. Now here in this question there is no mass given. Okay, so you will not be able to solve, but you if mass is given, you will be definitely able to solve. It is nothing but the matter of solving this equation and integrating. So you just need to put up the values. Dt by dt equals to Q dot, which is given as 3000 minus 600 by m into Cp. Okay, and Cp is nothing but given as 3.54. So based on what mass is given, you can solve this, and that will be nothing but delta T by delta T by integrating. Okay, so from this you will be able to calculate delta T, like time, what is required for increasing the temperature. So moving forward, which of the following is true for unsteady state process? So unsteady state process, what does that mean? It means that there is change in process variable with respect to time. Okay, so process variables change with respect to time. Obviously, that is the correct answer, and due to which the accumulation term in the mass balance cannot be neglected. So obviously, that is also correct. So both A and B are correct in this question, and variables do not depend on time. Obviously, there is wrong option given. So true options are A and B. Next question is, an exothermic reaction is taking place in a system. In order to maintain isothermal condition, as per the basic concept of thermodynamics, which option is correct? Okay, so here you have a reactor. Okay, and in that reactor there is one reaction occurring. Now what does exothermic reaction mean? Exothermic means heat is released, and this heat released will be taken up or consumed by the material or whatever is present in the reactor to increase the temperature. So temperature will rise. Okay, now you need to maintain isothermal condition. So what does isothermal condition mean? Iso means constant temperature needs to be maintained. So how can you maintain constant temperature? So since there is constant supply of heat by the reaction occurring, because as the reaction proceeds, and more heat will be released. Okay, and so temperature will rise constantly. So to avoid this temperature rise and to maintain a constant temperature, same amount of heat that is produced in the reaction, during the reaction, that same amount of heat should be removed. Okay, so continuous heat should be removed from the system. So here option B is correct. Now if you look into the another options, so heat should be supplied when the reverse case is there. So if the reaction is endothermic in nature, so heat will be consumed, which will result in temperature decrease. And so to maintain a constant temperature, you need to continuously supply some amount of externally heat. Now insulate, so this is for endothermic case. Okay, this is for exo. Now insulate the system. What does that mean? So insulate the system means you are stopping the heat exchange with the surrounding. So you are trying to maintain adiabatic conditions. So there is, you are trying to avoid um, the heat exchange. Next is also add more reactant. Okay, so adding more reactant will um, um, uh, obviously take up the amount of heat, but also more and more reaction might occur. Rate of reaction will get affected, and similarly, the rate of heat release will be affected. So this is not the suggested one option. So this is not correct. Obviously, continuous heat removal is suggested for exothermic reactions. So yeah, with this, uh, the assignment is complete for week 9. So if you have any doubt, you can tell me. Otherwise, I will stop sharing my screen. So if you don't have any doubt, I can stop sharing my screen, and I will end this meeting. So yeah, thank you for your attention. Thank you for joining.